Thank you for coming. My name is Jesse Rothstein. I'm the founder and CEO of ExtraHop Networks. I think we're going to have a really good session today. I'm looking forward to it. And the session is heavy on a demo, and it should be a pretty ambitious demo, as I've told a few of you in the audience. A lot of moving parts. You might get to see a dance that comes along with this demo. We'll see. A little bit about my background. As I said, founder and CEO of ExtraHop Networks. My background's really in application delivery controllers and load balancers. I was the lead architect at F5 Networks for about 6 years. And during that time, it was a great time to be there. That's when we brought application awareness to what was the load balancer and really created a whole new category that they still call application delivery controllers today. And that's when load balancers shifted from these high-speed packet processing systems to really the high-speed transparent full proxies that they are now. A great way to describe what we do at ExtraHop is we brought that same sort of application fluency. Our SVP of marketing says there's a difference between awareness and fluency. You could be aware that I speak Spanish, but you don't understand it unless you're fluent. But we brought that same application fluency to what was network monitoring. And we believe that's creating a new category that we call network-based application performance management. So one of the reasons I'm here is because of, obviously this is the Splunk conference, but it's really about the needs and the wants of Splunkers in general. And just front and center in Splunk base, you have really the most wanted, the top requested apps. And I think Splunk is a truly amazing platform for operational intelligence. But I think like any platform, in order to derive the proper insights, you need to provide the right inputs. This is the old, I guess, more terse way of saying that is garbage in, garbage out. So the right inputs are absolutely important. And one of the things that's loud and clear in the Splunk-based forums is that Splunkers want greater visibility to the complete application delivery chain. So that's visibility across the tiers, the network tier, the web tier, middleware, databases, and storage. But how do we get it? So there are technical challenges, which I'll go into more in a few minutes, but there are operational challenges as well. Operational challenges include just overhead associated with certain methods of getting that information. But one point that I want to really emphasize is that resource utilization is not the same thing as performance. It's valuable to track resource utilization, but there are a lot of systems that are designed to work at 100% CPU. There are a lot of systems that require tons of memory, and those are healthy systems. Performance is really given by application response time. It's given by the user experience. It's not given by resource utilization. I'm not saying that you shouldn't track it, but I'm saying that it's far from a complete picture. I think this is especially true with server virtualization. Because prior to server virtualization, we had a whole lot more overhead with regard to CPU and perhaps memory than we do today. I mean, I think that one of the real benefits of server virtualization is that we get to use some of that, what was previously excess CPU and memory, much more efficiently. Sometimes we even overuse it. Somebody, I can't remember who, put it really, really well, where they said that virtualization and cloud is like the airline industry. You have to sell more seats than you actually have. That's how you make money. So the ExtraHop solution, as I said, is network-based application performance monitoring. We take a copy of the network traffic and put it back together again. So even though this is a network deployment, I want to emphasize that we're not a network tool. Our vision is really that there's a ton of information available on the wire, and previously that information was largely falling on the floor. It's very hard to gather it. It's very hard to pick it up. It's very hard to put it together again. It's very hard to make sense of it. It's very hard to do that all in real time. But that's exactly the system that we built. So by sitting on the wire and analyzing the traffic, we put it all back together again. We extract the relevant health and performance metrics in real time. And for us, it's about ease of deployment. I think one of the things that's absolutely key is ease of deployment in dynamic environments and auto discovery. It's about industry-leading performance, a single ExtraHop 5000 appliance can do a full 10 gigabits of analysis line rate and support up to 3,000 servers or VMs. And it's about visibility across tiers, visibility into the network tier, visibility into the web tier, database, middleware, and storage. And it's our belief that network performance is really inextricably tied to application performance. These are not things that you can divorce from one another. It's part of that entire application delivery chain. So there's some challenges with network health and performance. For one, dynamic environments really require device and application auto discovery. Some years ago, the environments were much more static, but enterprise IT is at a bit of an inflection point where it's transitioning from a very static environment to a very dynamic environment. And we see that with the IT megatrends that we're all aware of. With server virtualization, VMs spin up, they spin down, they demotion across the data center. With cloud computing, we shift workloads to dynamic, elastic compute clouds. With mobility, devices come and go. We've got intelligent network devices. We have agile development practices where we roll out new versions of the app, not every 2 years, but now every 2 weeks. Extremely dynamic environment. It simply doesn't work to have to reconfigure your monitoring tools every time something changes in that environment. As I said earlier, network performance is inextricably tied to application performance, so holistic analysis of TCP is really required to provide insight into that. And then finally, and this is something I don't often talk about, but as somebody who used to build network equipment, I'll tell you that network equipment doesn't always provide the best estimation of its own health, especially when that health is bad. I actually remember at F5 how excited we were when we were able to get our load estimation at 50% to mean that you could truly double the traffic and that there was that much headroom left, that 50% was truly 50%. It sounds so easy, but it's really hard to do. So certainly collect the performance metrics, the resource utilization from the network equipment, but take it with a grain of salt. In terms of web servers, the single biggest challenge with logging at the web servers is the lack of visibility into payload. And I'll talk about that a bit more when we do the demo. But web servers can log headers, they can log URIs, they can even log processing time. They don't log payload. They also lack, and you'll see this as a common theme, correlation to network performance. And as I keep saying, network performance is inextricably tied. And then finally, you get all of these intelligent network devices, all of these caches, these WAN optimizers, these application delivery controllers that get in the way and really obscure your picture of performance. Application servers have similar challenges, maybe a little bit different. Often they require scripted inputs. Maybe you're using JMX scripted inputs. And let me just ask for a show of hands. How many people are taking app server metrics into Splunk? Can you just show me a show of hands? That's not as many as I would have thought. I was going to ask, of you who are taking those app server metrics into Splunk, how many of those are your own custom app servers where you can instrument it as you like, or how many of those are you dealing with third parties where maybe you don't have as much control? Well, I think it's fewer. So I probably didn't ask for that show of hands right, but I'm going to guess that it's fewer. And then, of course, inflexibility of logging options, especially with those third parties. Database servers are also particularly challenging if you want visibility into the internals of the database. Profiling is something that you can enable. You can enable SQL tracing. You can turn on audit logging. Ton of overhead for that. I'll talk about that in just a moment. But even once you turn on that audit logging, then that database performance metrics, they live inside the database now, and you need to do something like a scripted input to go pull that database and pull it out. And again, lack of correlation. So how much overhead are we talking about? Well, I pulled this off of Microsoft SQL Server's own site and technical information. And if you turn on SQL Trace, you get really between about 20% and 150% overhead just for running the tracing alone. And then to get the data back out of it, you're creating even more overhead. Now with something like the ExtraHop system, we're able to extract these health and performance metrics with no overhead at all in a completely non-invasive manner. And I said that earlier, but I'm just going to emphasize that again. And the way that we do that is we take a copy of the network traffic. You take a copy of the network traffic at the switch. You take a copy of the network traffic at an aggregation tap. It's really something the network team can worry about. Trust me, they do it all the time. And with a network tap, literally, you can bend the fiber and siphon off a little bit of the light. so that there's provably no overhead at all, except you lose 30% of the light, which is fine. That's what taps do. Storage devices. How many people were at the keynote yesterday? Did everybody catch the keynote? It was a great keynote. Good. See a lot of nods. One of the cool parts of the keynote was some of the integration that's coming up with the Netapp. I thought that was great, but I also noticed that integration was largely providing access to the Netapp's internal metrics. So you're looking at resource utilization, you're looking at counts around locking, things like some of the performance on a per filer basis. No visibility into per file and per user performance metrics. That's a little harder to do. It's a little harder to make it scale. It's a little harder to do without overhead. That's something that we can do in the ExtraHop system. And then, really, if you're looking for that, I guess I'll say it this way: the holy grail of monitoring is deterministic multi-tier correlation. And any vendor who tells you that they do this is probably lying, because it's really hard. In fact, you can never do this 100% of the time. But what I will say is that when the information is present, if there is a session cookie or a GUID or something that you can use to tie that information across tiers, then that's when you take it from impossible to possible. And that's exactly what something like the ExtraHop system along with Splunk can do. So the reason we're here at the Splunk conference is that we have introduced really sophisticated, powerful integration with Splunk. And it uses our framework that we call application inspection triggers. So application inspection triggers are a framework for real-time script processing on a per transaction basis. So that means on every single transaction, from the network perspective with no overhead at all, you can insert some analysis. And that analysis can record custom metrics, and that analysis can actually send that information using what we call precision logging or policy-based logging to remote syslog facility directly into Splunk. And there are hundreds of use cases. Our customers have been using this since we introduced this, and they introduce new use cases every single week. You know, we can limit the analysis to just certain clients. We call that client segregation. We can ignore errors that are benign. Maybe they're caused by service checks, and you don't really want to pay attention to those. We can do real-time profiling of your database or file systems. There's security implications. There's multi-tier correlation, which I mentioned earlier. Now, at this point, and I promise this, I'm going to do a rather ambitious demo. And there are a lot of moving parts in this demo, and it's really funny because I'm told that in the old days when you did an ambitious demo, you had somebody standing by to pretend to trip over the power cord if something goes wrong. But with laptops, you can't really do that anymore. So I'll ask you to just bear with me. So here's what I'm going to do. What I've done at this point is I actually have I have two virtual machines running simultaneously. I have a Splunk virtual machine running, and I have an ExtraHop virtual machine running. And I've actually set up a private network where these two virtual machines can talk to each other. And this is the ExtraHop, just sort of this is our summary dashboard display. But at this point, I'm going to show you the application inspection triggers. We're going to take these one at a time. The first trigger that I'm going to add is an HTTP trigger. So you'll notice that this trigger is on the HTTP response event. And what this trigger does is it's fairly simple. It sends an event to Splunk that we call an EH event. So we're sending a web event to Splunk, and we're recording the URI, the status code, and the T process. And what I need to do here actually is I recorded some traffic, and I'm going to start sending that traffic using TCP replay into the ExtraHop system. And as soon as I enable this trigger, that information is supposed to start going into Splunk. That's how this is supposed to work. So at this point, I'm going to go over to our ExtraHop Splunk app, and maybe in the last 15 minutes here. And I think, yep, sure enough, we're starting to see some information occurring on the website. I'm going to pull up the ExtraHop web dashboard. This is our Splunk app. It is available on Splunk Base. Actually, I'm going to do the last 15 minutes. And we'll notice that we're now seeing responses, status codes, and processing time. Pretty cool, right? I mean, completely real-time surgical locking, right? But I think I know what you're thinking. You're thinking, Jesse, that's pretty cool, but there's nothing there that I couldn't get from the web server log myself, and I'm already logging this stuff, right? Because I showed you status code, I showed you URL, I showed you processing time. Not that interesting. It's a little bit interesting when you consider that there could be a load balancer, there could be a cache on the way. Maybe you don't have access to the web server, but still not super interesting. So at this point, let me make this more interesting. I'm going to disable this trigger. Well, actually, before I disable this trigger, what I'm going to do is I'm going to drill down onto these status codes, because if you'll notice, all of our status codes here are 200 OKs. And you notice we're seeing this in Splunk, top status code, right? Everything we're looking at, can everybody read that? Yeah. Well, right now we've seen 289 of these 200 OKs. Actually, let me make sure that we're doing this real time. Yeah, 1063, 1118, 1125. You can see that it's pulling in the data, it's indexing it in real time. But let's make this more interesting. Let's disable this trigger, and let's look at a slightly more complicated trigger. And this is a trigger where I did the same thing as before. I did the URI, the status code, and the processing time, but now I've added the title. Well, now the title's a little more interesting. Now, I'm sure everybody here has seen a sorry page, right? Where the page says, we're sorry, the service you requested is unavailable, the site's unavailable, are bad, maybe it's a fail whale, I don't know. But the point is that on these sorry pages, the status code for the sorry page is still always 200 OK. You know, that doesn't change. But the title is often something a little more interesting. There we go. So now look at the titles we're getting into Splunk. Now we're getting titles that say, sorry, unexpected exception, sorry, page unavailable, sorry, page not found. This is not the same picture of health that we saw earlier with our 200 OKs. This is a very different picture. This is a picture of, you know, lack of health. So now what's required in actually getting a sorry page? This is what this particular sorry page looks like. And look at this. You know, the sorry page has to be pulled out of the HTML. You have to parse it. You have to pull out the sorry page unavailable. You have to find the title, if it's even there, inside the head. And you need to extract that. And that's exactly what the ExtraHop system here is doing in real time. This is what we call our basic payload analysis. Now, I think that's kind of interesting because looking at Apache, looking at IIS, looking at your web server logs, that information is not available. That's not something you can log. And what's even more interesting is that load balancers and application delivery controllers, take it from me, they insert sorry pages like this all the time. F5's Dev Central has some great iRules to do that. So even if you think you're logging it from the web server, and I don't know how you would, this could be coming from the load balancer. But let's take a slightly different case now. Let's imagine more of a web service, where this is actually a real web service. I pulled this out of the documentation for an extremely popular payload processing protocol. So this is the web service that's used for payload. I'm sorry, I said payload processing, payment processing. This is a web service that's used for payment processing. Obviously, it's an XML format, and I'm just going to highlight some things. In here, we see a username, we see an account number, and there's an order ID. So for this one, I'm going to pull up a slightly different trigger. This is our XML payload trigger. And you'll notice in this trigger, what we're doing is we're looking at the request, we create an XML object, and then we take the user, the merchant ID, the account number, and the order ID, and we send this to Splunk through that remote syslog service that I've been talking about, all completely in real time. So now I'm going to go to Splunk, and I don't know if you noticed I moved that kind of quickly, but that was a different EH event. That was not the web event. That was actually the XML event. So if I look at the XML event, sure enough, we see these merchants, the merchant IDs coming up, we see the account numbers, we see the order IDs. But let's imagine a particular troubleshooting scenario. And this is one of these classic ones where you talk to somebody who does this, and they might be searching for this for months. They say, you know, we think that there's something in our environment that's sending duplicate transactions, but we're not sure. Can we prove or disprove that this is actually happening? And by logging all of these transactions into Splunk, the answer is that yes, you can. And here we're going to create a transaction on the order ID and search for anything with an event count of greater than 1, which you'll notice, there I found it, I caught it red-handed, right here with merchant ID 213122, we are seeing duplicate transactions. That is extremely powerful. If anybody deals with anything transaction-oriented and you're searching for, this is not a needle in a haystack, this is a snowflake in an avalanche. And this is what we've done with our integration with ExtraHop and Splunk. But wait, there's more. Because that was a little bit of a HTTP analysis and HTTP payload analysis. If we add on what I kept talking about in the beginning, the correlation of, basically HTTP web server to network metrics, well, we start adding in metrics like, what were the bytes at L2? We could add metrics. This is incomplete. This is just some. We could add metrics around good put. We could add metrics. Here we added request retransmission timeouts and response retransmission timeouts. Those give you some indication of whether you're seeing loss on the network. We can add metrics around time to last byte, which we call here the network processing time. That includes basically the response transfer time and the amount of time that it takes to send the payload over. So for that, I'm going to go back to my web dashboard, and here's what those look like. And I preload this one with some more metrics that look interesting. But in this one, we graph some of the web status codes and responses, along with some of these network metrics like bytes and the actual network processing time as it relates to the server processing time. So that's part of that correlation I'm talking about. That's part of that complete picture in the application delivery chain. And I think it's even more important with mobile devices, because mobile devices have notoriously unreliable networks. Mobile devices are coming over, well, we hope not GPRS anymore, but certainly 3G, certainly LTE, and these wireless networks that are really unreliable. Tons of jitter, tons of slowdown. When people complain about performance, you need to be able to figure out, is this a network problem or is this an application problem? The next one I want to show you, and how are we doing on time? I should check on that. I think we're okay. The next one I want to show you here, I didn't do so much of a complete run through with time, so I want to make sure we're okay. Is database. And before I do that, let me kick off some database traffic here. I've got this in a different traffic script. But here you'll notice that I configured a trigger on the database response event. And what this trigger does is we're recording the database method, the user, again the size, and if there's an error, we're recording that as well, and we're also recording the database processing time. Now, there's much more we could record than that. We can actually record full SQL statements, but in the interest of privacy, that's actually not something that I'm doing here. But what I do want to show you is I'll show you what this would look like in the ExtraHop system. So if I go to this Oracle database that we've got, and I go to my database metrics, you'll notice that I can pull up things like by default we'll record the method that's being accessed, the table that's being accessed, the processing time. You can drill down on a per user basis. There is a treasure trove of information here. This is where, and this is not just a tool for DBAs, but this is where you can determine, well, is my application slow because of some problem with my database? Is my database slow? Is it using unoptimized queries? Is it missing an index? At one customer site, they actually rolled out a new version of the application, and it was much slower. They were hoping it'd be faster. It was much slower. So they took a closer look, trying to figure out what it was, and the database was as fast or faster than it had ever been. But when they took a closer look at the queries, it was doing about 10 times more queries than it used to. And they went back and talked to the app developers, and it turns out what had happened was they had modularized the app such that you had all of these modules that weren't sharing as much state as they used to, so they were all duplicating the same queries, causing pretty massive slowdown to cascade up. Now in this case, we're actually sending these database events not just to ExtraHop, but to Splunk, and I can pull this up in our database dashboard here, which you can see here in the last 15 minutes, the metrics are starting to show up, and we're including the top methods. We're including errors, and we are seeing a few errors which might be useful to drill down to, and we're seeing what else we got? We've got the throughput, we've got the response time. I don't think I even practiced this one, but let's just view the results and see what these errors look like. I'm going to do, what are the top errors? Okay, so we can see that there are specific errors here in terms of missing APIs, in terms of mostly looks like APIs not existing. Sometimes we see errors in stored procedure calls. 5-minute warning. Okay, I've only got one more here, and I'm gonna try to save some time for questions. My last one that I've got was a storage example, and here you can see another trigger for storage. As I mentioned earlier, we have visibility into files, into users, into what we call access time, which uses a set of heuristics that we built to determine how slow is it to access a file. Notice that's not the same thing as transfer time. What's tricky about network storage and your file-based storage in particular is you don't always transfer the whole file. Sometimes you edit it in place. This is what happens when you open up your Word on a network share or something like that. So just kind of looking at the storage, you notice the tree control here is populated. ExtraHop starts getting this file information right away. We can look at the access time. And we're sending this to Splunk as well, so I can go to our storage dashboard, and you can see we're starting to get that information here into Splunk. But at this point, I want to make sure I give at least a minute or two for questions since I'm going long. Any questions from the lovely audience? Question in the back. That's a great question. The question is, what databases do we support, and specifically, do we support Cassandra and MongoDB, which are not traditional relational databases? The answer is we support pretty much every major enterprise database. So we support SQL Server, Oracle, MySQL, DB2, Informant, Sybase. We support Memcache in terms of your in-memory data store. Cassandra and MongoDB are requests that we definitely hear frequently. We might add that to the roadmap. Those are not available today. Next question. But I'd be interested in having a follow-up conversation with our product management to figure out what you're looking for. Yes? Encrypted traffic. Great question. So the ExtraHop system, recall, is an appliance. And by looking at the network traffic, if that's encrypted, traditionally you'd be out of luck. We do support real-time high-speed SSL decryption if you load the private key in the certificate. On our hardware appliances, we built our own real-time SSL decryption stack. We do this with a cryptographic accelerator. We can do this at 10 gigabit line rate. We can do tens of thousands of handshakes per second. On our virtual appliances, without the hardware, we're still pretty good, but it's a little slower. And I do want to mention, I don't think I mentioned this earlier, is that not only do we have a line of hardware appliances, we do have a line of virtual appliances as well. Next question. Jim. Support for things like Citrix. I think that's a softball question because Jim knows that we actually have what I believe is industry-leading support for the ICA and HDX protocols. Most of the products on the market really just scrape information out of the Windows event log. What we actually do is we analyze these protocols in real time. We are Citrix's chosen partner for real-time analysis of their thin clients and VDI. We can crack open the virtual channels. We can tell you who's watching YouTube videos. We can look down at the per application metrics. I don't have time to go into this, but one of our users is in this very room at Concur, and not only are they a big Splunk user, but they make a lot of use of ExtraHop for real-time database profiling. We have a really good case study at our booth if you want to learn more about it. And again, I don't want to put the individual on the spot, but there is somebody in this room right now who knows an awful lot about this. Our customers tend to say really, really good things about us, and many of the customers on this list use Splunk and they use ExtraHop, and and they use something else. And that something else is hard to say. Usually it's a third thing. It's a SolarWinds, or it's maybe it's a Keynote, but we see Splunk and we see ExtraHop and we see a third thing, and that's what they're using for complete visibility into their network and application environment. So finally, to wrap up, I would urge you to take a look at our solution page. We do have our Splunk app up on Splunk Base, and we have an ExtraHop virtual appliance called our Discovery Edition. If you come by our booth, we've got a flyer that'll tell you how to get a hold of one of those. It's a pretty fully featured edition of the ExtraHop appliance you can run in a VMware virtual environment. Maybe time for one more question? Yes? So question is about custom decodes. Something that, so with our application inspection triggers, you have a great deal of flexibility around custom metrics. So any protocol that we support on a per transaction basis, you can add custom metrics for. We actually have an open API to get the data out of our system as well. Obviously the Splunk integration, custom decodes are not available yet. But if there's something that you want that you think is has reasonably broad appeal, I would urge you to come talk to us, because everything is built on top of our intelligent protocol framework. So custom decode is something that I could imagine doing. Certainly in our development team, it's just not something that's open to third parties at this time. Any other questions? I was also asked to request that you guys fill out the survey. If you fill out the survey and you give me good marks, they might choose to have me back again next year, and if not, they'll probably give me the brush off. So I would appreciate that. We'll call it a personal favor. Come by the ExtraHop booth. Thank you.